this is the key thing here. So as I go up and to the right, smaller radius, smaller volume, higher ionization energy, higher electron affinity, higher electronegativity, more non-metal-like, more likely to gain electrons. As I go down and to the left, larger radius, larger volume, lower ionization energy, lower electron affinity, lower electronegativity, more metal-like, more likely to lose electrons. So with this, we can practice some, right? Magnesium or calcium, which one's going to be smaller? Magnesium or calcium?
Magnesium.
Yeah, magnesium smaller. And it's up and to the right. Nitrogen, oxygen, which one's smaller?
Oxygen.
Yeah, oxygen. So this one,
Oxygen.
magnesium was up, oxygen was to the right. So here's an interesting one. What if you have an opposing trend? What about nitrogen, sulfur? Aha. So you guys see the periodic table over there?
Yes.
Which one's going to be smaller?
Nitrogen.
I'm going to predict nitrogen. Why? That's exactly right. Why did they say nitrogen?
Because it's still like going up.
Well, but the sulfur's to the right.
Because trumps.
Yeah, up. I'm going to
Is it up trumps?
trumps right. If I go 2 over, if I compare nitrogen, chlorine, then they're probably very similar. Too hard to tell without a chart. So in that case, it's kind of a, I don't know. But generally, if you have a simple opposing trend where they're adjacent, nitrogen and sulfur, I'm going to choose up over right. If we do sulfur, fluorine, it's no contest. The fluorine's both up and right. Does that make sense?
Mm-hmm.
Okay. So, and I could ask the same question. Instead of saying smaller, I could cross out smaller and say, what has a higher ionization energy, right? Or I could say, what has a stronger electron affinity? Same kind of result. There we were playing with the same idea. Which has the largest atomic radius, magnesium or calcium? You do the same thing. So in this case, before you do it, you kind of have to say to yourself, you have to say, hey, wait a minute. What is the trend for largest? And so largest is, well, it's down to the left, right? So that's why calcium is down, so it wins, right? So that's kind of the, let me put a question mark. That's kind of what you have to ask yourself before you do those. Oxygen or fluorine? Look at your periodic table. Fluorine's to the right, so which one's going to be larger? So oxygen would have to. This is another trend too. So atoms, so this is lithium versus fluorine are both in the second period, and fluorine is smaller. But once fluorine gains an electron, you guys see the arrow, once it gains an electron and becomes fluorine ion, the ion is bigger. When lithium loses an electron, it essentially loses its second shell. It becomes much smaller. So that's a really important idea. Cations are smaller than their neutral atoms. Anions are larger than their neutral atom. down below, they're showing a crystal, a very microscopic crystal of sodium chloride. So anyways, in the sodium chloride crystal, sodium ions are really small and the chlorine ions are really big, right? And that's why they tend to pack the way they do. You can also predict size for isoelectric atoms. So for any isoelectric series, as the number of protons increases, the size decreases. So if I look at sulfide, chloride ion, potassium ion, calcium ion, scandium ion, all of these are isoelectric. They all have, let's put a text down here. They all have the electron configuration of argon, right? If chlorine gains 1 electron, it gets to be like argon. If potassium loses 1 electron, so then you basically say, I have the electron configuration of argon, but potassium has 19 protons, and chlorine, how many protons does chlorine have? 17. So potassium has more protons. Let's put the ion here. Potassium plus has more protons than Cl minus, but they have the same number of electrons, right? So if they have the same number of electrons, but potassium has more protons, it's going to be smaller. So we can, this is a different kind of periodic trend. You can do ion size for what they call isoelectric atoms. So this is showing that the ions, these are isoelectric ions across a period. Let's just look at the third period, right? So phosphide ion is huge. Sulfide gets smaller, chloride gets smaller. And then I guess the one they're not showing is argon. Argon would be a little smaller than chloride. So potassium would be smaller than argon and chloride, and then calcium would be smaller still, right? So this is showing the relative sizes of ions. We can practice these. So the general trend is for ionic size, for ions to increase from top to bottom. I guess that's our trend. So it's, and then there's kind of this kind of lopsided half trend, right? If I look on a given period. For cations, as the charge increases, the ion size decreases. For anions, as the charge decreases, becomes more negative, the ion size increases, right? So if we look at any one of these, the fluorine is -1, oxide -2, nitride -3. Nitride is going to be much bigger than fluoride oxide. Okay, so that's the basic idea. Isoelectric comparison. Something like rank order in decreasing size. Argon, sulfide, potassium, calcium, right? And so for these, you'd have to say they all have 18 electrons. So which one's going to be, so we want decreasing. That shouldn't be sulfide 2+, that should be sulfide 2-, excuse me. Which one's going to be the biggest? Sulfide has 16 proton pluses, 18 electron minuses, right?
Yes.
Argon is the noble gas, so it's 18 and 18. Potassium would be 19 and 18, and calcium would be 18, and 20. So which one's going to pull in the electrons the most?
Calcium then?
Yeah, calcium would be this one would be the smallest. Actually, it's kind of I need another pen. Calcium would be the smallest. So actually, I'll put calcium, and it's 2 plus 1. Okay, and then potassium would be, actually, I just put them in order, didn't I? I just kind of naturally do that. But anyways, this would be the biggest. This would be the smallest. These technically, if you just practice them on the homework, these should be super easy questions on a test. Does it make sense?
Yeah.
Yeah. Okay.